Hi everyone, this is the first video for section 3.4, dividing whole numbers. So like always, make sure you've read this section in the book, just so this video will make more sense when you watch it. Okay, so far in chapter 3, we've talked about addition, subtraction, and multiplication. So division, right, this new operation that we're going to talk about is really related to these. So just like subtraction was the inverse operation to addition, division is the inverse operation to multiplication. So we can use what we know about inverse operations to talk about division, but also we know that just like multiplication was repeated addition, division is just repeated subtraction. So we can use everything we know about multiplication and how it relates to addition, and division and how it relates to subtraction to talk about dividing whole numbers. So first off, we'll talk about the definition of division. So you see that dividing a number b by a number n is defined as saying that b divided by n equals a if and only if a times n equals b. So this is essentially saying that we define this division in terms of multiplication, right, as the inverse operation. So we can say that we have b divided by n equals a if a times n equals b. So we can see that this is why these two are inverse operations. So if we take b and we divide it by n and we get a, okay, well, what happens if we take b divided by n and then we do the inverse operation by multiplying by n? Well, this b divided by n is just a. When we multiply it by n, based on the definition, we get that this is b. So you can see that this definition makes it so that division and multiplication actually are inverse operations. So then how do we talk about these things? So we talk about them using the specific vocabulary. So the thing that's being divided is the dividend, and the dividend is divided by the divisor, and we get the quotient as our answer. Yes, I didn't really need to write that because it's all right there. So we have the thing being divided is the dividend, the thing we're dividing by is the divisor, and then our answer is the quotient. Okay, so these have different names, right? It's not just with multiplication. We multiply factors to get the product. So we have that the first number and the second number, the dividend and the divisor, have different names. And that's exactly because of this commutative property. So we have that it's because of the commutative property. So this does not hold because division is not commutative. So it matters what order we multiply numbers by. So for example, if we do 12 divided by 6, we all know that that's 2. But if we do 6 divided by 12, well, that's 1/2, right? And so those are not equal. They are not the same. So since those aren't equal, we can see that division is not commutative, and that is exactly why the thing being divided is the dividend and the thing we divide by is the divisor, right? Because they are different things. And we can't just change them and get the same thing. So now let's talk about associativity. So remember that this is the grouping. So do we associate the first two things or do we associate the second two things? So associativity, well, again, division is not associative. Because if we just take a similar example, if we do 12 divided by 6, and then we divide by 2, this is 2 divided by 2. Sorry, these division signs haven't been that easy to make look nice. So 12 divided by 6 divided by 2 gives us 2 divided by 2, which is just 1. But if we do it the other way around, we take 12 and then we do 6 divided by 2 first. Well, this is 12 divided by 3 which is 4. And again, these are not equal. Okay? These are not equal. So division is also not associative. So the next property is the identity property, right? Do we have something that whenever we divide by it, that the number stays the same? Well, yeah, we do. We know that A, we take any number A and we divide it by 1, that's just going to give us A back, right? So we know that there's this number 1, the multiplicative identity, that if we divide by that identity, we're just going to get the same thing, right? We take A and divide it by 1, it's just going to give us A. However, remember the identity has to work both ways. It has to work as A divided by 1 and 1 divided by A. And we know that 1 divided by A is 1 over A. And these are not the same for every number. So yes, this is true if A equals 1, right? If A equals 1, these are the same thing. It's just 1 divided by 1, which is 1 both times. But remember that the identity has to apply to every number that we're dealing with. So since we're still dealing with whole numbers, this identity should work for every whole number, and clearly if A is not 1, if it's a different whole number, this isn't true. So these aren't the same, but we can see that just like subtraction, this has a right-hand identity. Because if we have the 1 on the right, it is an identity, but if it's on the left, it's not. And then lastly, distribution. So you may be very tempted to say, well, none of the others have worked. This one probably won't work either. But in fact, distribution is a property that division has. And it looks like this. If we have A plus or minus B and divide it by C, we can take that, and this is the same thing as A over C and B over C, and depending on if we added, subtracted in that numerator, we add and subtract here. So division does have this distribution property. So this is the one thing that does hold, and this essentially is going to come from the fact whenever we get to dealing with fractions, we can see that this is actually defined as A plus or minus B over C is actually defined as 1 over C times A plus or minus B. And so because we have this distributive property for multiplication, and because we use multiplication to define division like this when we deal with fractions, that's why this in fact does have a distribution property. So yeah, we don't have the first 3 things, just like subtraction, right? We didn't have any of these things in subtraction, so we don't have it in division when we just repeat subtraction, which makes a lot of sense. Okay, so the last thing I want to talk about on this first page is division with 0. So we've talked about, right, the basic definitions of division, some properties division has, but now let's talk about division with 0, because this is something that comes up a lot as something that is just a little bit confusing for people. Okay, so the first thing is, can 0 be divided? So let's think back to our definition. So we can take 0 divided by some number A equals B if and only if and only if we can write A times B equals 0, okay? And we know that whenever we talked about how the right 0 is the multiplicative, sorry, it's not the multiplicative identity. Remember that 0 is the additive identity, right? So whenever you add a 0 to something, it doesn't change. So remember when we talked about multiplication, that we talked about multiplying by this additive identity. So when we multiply 0, we just get 0 back. So if A or B equals 0, then that means that A times B is 0, right? Based off of that formula. So that means that for any A, a times 0 equals 0. So that means that we have that 0 divided by a is 0. So yeah, 0 can be divided because there is something we can multiply by any number to get 0, and that is 0 itself. Okay, so 0 can in fact be divided. Okay, so now let's think about, can we divide by 0? Okay, so again, we're just going to use this definition that we had. So we can take a and divide it by 0 to get some number, divide by 0 and get some number b. We can do this if and only if we can take b times 0 equals a, right? Just by the definition, we take our quotient times our divisor to get our dividend, right? That's how we define division at the beginning. Okay, so if b times 0 equals a, then we can divide a by 0. Well, again, just like we talked about with the first question, we know that based off how multiplication interacts with the additive identity, well, this happens. This means, so b times 0 equals a means that a equals 0. Okay, and so if we have that a equals 0, then that means that we have 0 divided by 0 equals b. And we don't need b to be anything specific, right? Because we have 0 times any number is 0. Well, then that, by this definition, means that 0 divided by 0 can be any number. And this cannot happen, right? Remember, we talked about back in sets, right? Back in chapter 2, we talked about a set being well defined of, if you have this property, can you clearly tell if it's in the set or not? So this is another instance of something being mathematically not well defined. So this cannot happen because we need something to happen, right? We can't have 0 divided by 0 be any number possible, right? That doesn't make any sense, and it kind of breaks a lot of things if we could have 0 divided by 0 be any number. So this is something that's not well defined, because we have that 0 can be any number there, and we have that b can be any number, and that's not going to make any sense. Okay, so this was just kind of the basics of things. So what division is, what properties does it have, and what about dividing by 0? So this is just kind of the introduction to division. In the next video, we'll talk about actually how we do division. Again, there's going to be algorithms and models and things like that. And so that'll be next video, but that's all for this one.